We're going to continue on with the blood vessels and talk about the veins. So the veins have a larger lumen than the venules, so their resistance is going to be really low, so they're like a really wide straw. Veins also have very thin walls, and that's because they have very low pressure. So remember, they're pretty far away from the ventricles where all that pressure is being generated, so you don't need very thick walls in the veins. The veins are also surrounded by smooth muscles, so you can vasoconstrict and vasodilate the veins. And veins have a much higher compliance than arteries. So remember, compliance is how easy it is to stretch something. So the veins are like a very easy to stretch balloon. So they're really easy to stretch, and because of that, they act as volume reservoirs. So they can hold a lot of blood with very little change in the blood pressure, just because they just keep stretching out. Because the pressure is so low in the veins, the blood can flow backwards. So we do have valves in the peripheral veins to keep the blood flowing in one direction to the heart. So the only veins where you don't have valves would be the veins that are in the chest cavity and also the veins that are in the brain. But everywhere else you're going to have valves in the veins to prevent blood from flowing backwards. This graph is just showing you how the veins are going to be volume reservoirs. And if you just take a look at a particular blood pressure, whatever this is, and if you have that same blood pressure in the arteries versus the veins, you can see that the veins will stretch out a lot more, and they're going to hold a much larger volume of blood than the arteries do. So it's important to remember that veins are volume reservoirs, and remember, arteries are pressure reservoirs instead. This graph shows the blood distribution at rest, and you can see that 60% of the blood, it will be in the systemic veins and venules at rest. So that's why veins are called volume reservoirs. So when you start exercising and you need to get more blood flowing to the muscles, it's very easy to just vasoconstrict the veins, and that will push blood out to the rest of the body. There's 4 factors that affect the venous pressure, or the pressure inside the veins. And the venous pressure will also then affect the blood flow to the organs. So we have skeletal muscle pump, respiratory pump, blood volume, and venomotor tone. So we'll talk about all 4 of those. But if you increase the venous pressure by one of those 4 methods, that will squeeze more blood back to the heart. So you increase the venous return to the heart. And that'll increase the end diastolic volume. So you'll fill up the heart with more blood. That'll stretch the ventricle closer to the optimum sarcomere length. And then the ventricle will contract harder, and that will increase the stroke volume. So more blood will be squeezed out with each beat. And if you increase the stroke volume, that's going to increase the cardiac output. So remember, when we calculate cardiac output, it's heart rate times stroke volume. So if you increase stroke volume, that'll increase the cardiac output. And if you increase the cardiac output, or the blood flow, you're also going to increase the MAP, or the blood pressure. So let's take a look at our skeletal muscle pump. So the skeletal muscle pump comes in play when you're exercising. So when the skeletal muscle contracts, it's going to squeeze on the veins and push blood back towards the heart. And then when the muscle relaxes, the veins no longer squeeze, but the blood can't flow backwards because you've got the valves inside the veins to prevent that. So if you're exercising and contracting your muscles, that'll increase the venous return to the heart, which will increase the stroke volume, because we're going to increase our end diastolic volume. That'll fill the ventricle more, stretch it closer to the optimum sarcomere length, and that'll cause the ventricle to contract harder, and that will increase the stroke volume. And if you increase the stroke volume, that will increase the cardiac output, or the blood flow. So that's good, because you need to increase your cardiac output or blood flow while you're exercising and get more blood flowing to the muscles. Here's a picture showing you the skeletal muscle pump. So when the muscle contracts, you can see that it pushes on the vein. That'll increase the venous pressure and push more blood back to the heart. And then when the muscle relaxes, it's no longer squeezing on the vein, so the pressure will drop, but you've got the valves that will prevent the blood from flowing backwards. The respiratory pump also increases venous return to the heart. This is important when you're exercising as well, because when you exercise, you're going to be breathing faster and deeper. When you inhale, if you look at the picture on the bottom, your diaphragm, when it contracts, will move downwards towards the abdominal cavity. That'll increase the pressure on the abdominal cavity and decrease the pressure in the chest cavity. So you create this pressure gradient where blood flows from high to low pressure, so that will squeeze more blood back to the heart. So if you increase the venous return, that'll increase the end diastolic volume, which increases stroke volume and cardiac output and MAP, which is all what you want to do when you're exercising to get more blood flowing around to the muscles. When you exhale and the diaphragm comes back up, the pressure in the abdomen will decrease and the pressure in the chest increases. But there's valves in the abdominal veins which will prevent the blood from flowing backwards. So what happens when you breathe faster during exercise is you're going to increase the venous pressure, and that'll increase venous return to the heart, which will increase stroke volume, cardiac output, and MAP. The third thing that will increase or decrease venous return is blood volume. So if you increase blood volume, so it's just like if you have a garden hose and if you put more water into it, you're going to increase the pressure. So if you increase your blood volume, that'll increase the venous pressure, which will push more blood back to the heart, increasing venous return. And then if you push more blood back to the heart, you're going to fill the ventricle up more, so that'll increase the end diastolic volume. That'll stretch the ventricle closer to the optimum sarcomere length. The ventricle will contract harder and squeeze out more blood with each contraction, so that'll increase the stroke volume. And if you increase the stroke volume, that will increase the cardiac output or the blood flow. And then if you increase the cardiac output, you also will increase the mean arterial pressure. An example of increasing blood volume and causing increased blood flow and higher blood pressure would be in kidney failure. So if the kidneys are not working well and they're not able to get rid of the excess water in the body, that all builds up and stays in the blood and increases the blood volume. Decreasing blood volume, we have several causes for that. A good example would be blood loss, dehydration, you've lost a lot of water from the blood, or when you stand up too quickly, the blood pools in your legs, and that's when you get kind of dizzy as well. So if you decrease your blood volume, there's not going to be as much blood in the veins. That'll decrease the venous pressure. And if there's not as much pressure in the veins, you're not going to push as much venous blood back to the heart. So if you decrease venous return, that'll decrease the end diastolic volume. You're not filling the ventricle up as much. And then that will decrease the stroke volume because now the ventricle is not going to contract as hard and squeeze as much blood out with each contraction. And if you decrease the stroke volume, that will decrease the cardiac output, so it will decrease blood flow. And if you decrease cardiac output, that will decrease the mean arterial pressure. And the last thing that affects venous return is called venomotor tone. So the smooth muscle in the walls of the veins, they're innervated by the sympathetic nervous system. So if you increase sympathetic activity, the smooth muscle contracts, that'll cause vasoconstriction of the vein, that'll increase the venomotor tone. And if you've constricted your veins, then that'll push more blood back to the heart, so that'll increase the venous return, and then that will fill the ventricle up with more blood, that'll increase the end diastolic volume. And if you increase the end diastolic volume, that'll increase the stroke volume, so we'll pump more blood out with each contraction. And if you increase stroke volume, that increases cardiac output. And if you increase the blood flow or cardiac output, that also will increase the mean arterial pressure. So if you vasoconstrict the veins, that will increase cardiac output and increase MAP. This diagram just shows the 4 factors that affect venous pressure. So we've got our skeletal muscle pump, respiratory pump, venomotor tone coming from the sympathetic nervous system, and then also blood volume. So all 4 of those things will affect the venous pressure, and that'll affect the cardiac output and the mean arterial pressure.